This is an Explorer Scientific First Light, which is kind of like a beginner model, or I consider it just to be casual use. And it's got a 4-inch refractor. So this part here is the polar axis. So what it amounts to is, if you could look right through here, which some telescopes have a polar scope, this one does not, you would be looking through towards Polaris, the North Star. So you get that there, and then the idea is that you follow the rotation of the Earth so that stars stay in the same position. First thing you do is you got to know what your latitude is. So I live in Terre Haute, Indiana. It's about 39 degrees here. There's a little indicator there, so you set that on that. Okay, so first you got to get it pointed properly to the north. North is right up there towards that dead tree. Now, depending on where you live, due to trees, lights, buildings, whatever, you might not even be able to see the North Star. But if that's the case, you can just use a compass and just figure out where north is and get it as close as you can. Now, the way I've got this set up, this front leg is the one that's on north, and these back two, the line going from here to there is your east-west line, so then that's your north-south line. Last night I had it out and I got it aligned pretty good, and I made quick reference marks. I'll show you that a little closer. Okay, all this is, last night when I got it set up where I wanted it, I put duct tape down on all 4 sides of the tripod leg and then sprayed it with black paint. So I'm going to have 3 black dots, and then whenever I come out here I can just set the tripod legs on those 3 dots and I'll be set up. Each of the 3 dots on there. And you can see they're not perfect, but that's close enough. That gets you, if you get that there, you're in the ballpark, and with something like this, you'll be in good shape. That'll just keep you from having frustration. So here's the counterweight. This weighs almost 6 pounds. And the idea is you have that on this end and the telescope up here, and you just get a balance. This little nut bolt here, a lot of them, they call it a toe saver. It's just to keep the weight from sliding off and landing on your foot in case you accidentally have something go wrong. And I've got a piece of tape on here which you might see. I marked where I had this set for balance. Snug that up and just put in my little safety bolt here. Okay, so here's the part you really wanted to see. This is the telescope itself. It's a 4-inch refractor. It's 1,000 millimeter focal length. So to mount this on here, I just had to put, this part here is called the dovetail bar, inside the little cradle slot, and then I tightened up the nut there. So you want to make sure it's in there good and secure. And this part here, these are the tube rings. If you unloosen this, it opens up. It's kind of like a half circle. So when you balance it, you just get, it's kind of like a teeter-totter idea. You just want it to be to where you can move around without one end just slamming. The lens end here is heavier. And speaking of, there's the lens cover. Now this particular telescope has manual controls. So that means there's no electric tracking motor, which is great if you don't want to have to worry about batteries or power cables or anything. If you're wanting to take photography, you can do a little bit with this. You can take pictures of the moon, and there's people that even get some shots of the planets, but you got to have a lot of patience. This is the east-west, this shorter one. This is the north-south, the declination. So this is right ascension or east-west. This is north-south or declination. So the east-west is the one you use to track the motion of the object you're watching, if you're planet or moon or whatever. So here's your eyepiece holder and the eyepiece. It came with a 25 millimeter eyepiece. It's called a Plossel. That's just the design. It's a fairly wide field. And FMC just stands for fully multi-coated. It's a generic eyepiece, really. It's not very expensive, but it's not bad. And you can rotate this just for comfort, depending on where it's easiest for you to view. Then this part here is the finder. It works. I'm not real impressed with it. It's good for finding the moon. The only issue I have with it is when I'm looking through it, the little glass on it kind of dims the star. Now, of course, when I was looking, the sky was a little bright and the moon was out, so maybe that was part of it. And when I turned on the LED is adjustable on how bright it is, and I thought its dimmest setting was a little too bright. Now, something I like about having this long telescope like this is you can put your head down here and look right up this tube or barrel, kind of like if you're aiming a bow and arrow or a rifle. If you see the moon or a bright star, you can point at it and you can tell if you're off a little or a lot left and right. In this case, that's north and south. The same thing with your east and west. But just a little bit of practice, it's not too difficult to find and center an object if you're using a low power eyepiece. Now, since this telescope has such a long tube, when you point it high in the sky, the eyepiece starts getting kind of low. Now, this thing's really nice for sitting in a chair. Last night I looked at Jupiter for probably an hour and a half or more. So as you see, this is a pretty good telescope for sitting down. And if your polar alignment's really good, basically this one here is the only one you move. Like I say, I was using it for like an hour and a half last night. Once I got started, I had an eyepiece in at 111 power. It was a 9mm, and it stayed centered real good. The north and south wasn't giving me a problem. If your polar alignment's really bad, you'll be moving both of these a lot. And then I'll, let's say whatever you're looking at is getting really high in the sky. But just something else I wanted to show. These cables run into each other here. So once I'm following it from the east over to the west, and when I get about due south, the two cables kind of bump into each other and you can't go any farther. So you just move it to the other side. And now you're on the telescope is now on the east side. So now it's easier. Say the object is in the south, it's due south. As it goes farther west, getting lower in the sky, down close to the horizon if you don't have trucks and trees and whatever in your way. And on the other side where I had it, you'd start really low in the east and come up. So that's one thing about an equatorial mount. They call it a meridian flip. The meridian is when you get due south. It's just when you cross, and that's the highest point. They also refer to it as transiting. If you're looking at a chart, they might say that, say the planet Jupiter rises at 6 p.m., transits, which means it's at its highest point at, let's just say midnight, and then sets at, let's say 6 a.m. And those are just, I'm just pulling numbers out of my hat. All in all, I'm quite happy with it. I wanted something that was lightweight that I could take with me if I'm going someplace. Because most of the time when I do stuff, I come out here in my driveway, and my other telescope's a lot heavier. And plus this here, it's a real simple setup. I don't have to have any batteries, any cables at all if I don't want to. Let's see, I looked at Jupiter. I started off at the eyepiece here, which is 40 power. And the planet's really small, looking at that power, but I could see all of its moons. And then I went up to about 65 power, I think it is, with a 17mm eyepiece that I already had. Remember, this just comes with one eyepiece. And that looked really nice. And then I noticed one of the moons was coming out from behind Jupiter. I just suddenly saw this little bright dot that looked like it was touching the side of the planet. So I went up to my 9mm eyepiece and I saw it was definitely a moon coming out. And then I went and looked at my computer to see which moon it was, and it was Io, and I noticed that the great red spot was coming around to this side of the planet to where you could see it. So that's one thing you want to remember. The Jupiter rotates like once every 9 hours or something like that. So the red spot's not always facing you. You can't just look up there and automatically see it. Well, I was lucky. It was just coming out. And at 111 power, after I looked for a couple minutes, I could see it. And at that magnification, it looked like just a little dark dot on the planet. It looked like it was about the same size as what the moons look like. So if you're ever looking for it in your eyepiece, especially if you're not real high power, just look for a little dark dot that might look a little red on the surface of the planet, and it'll look like it's about the same size as the moons. And as it, if it starts its way out on the edge, it's a little harder to see, and as the planet rotates and it gets towards facing you, it's a lot easier to see. But the focus on this thing was really sharp. A lot of people with refractors complain about what's called chromatic aberration, which is, it's basically a rainbow effect. This is an achromatic refractor, which means it's been corrected somewhat. If you get one that's apochromatic, it might cost 10 times as much as this. I don't want to spend that much money. If you get, there's nothing wrong with doing it, but not for me. The focus was really nice, smooth. The controls here, they're nice and smooth. I wish the cables were longer. Last night, maybe it's because I figured out where to position the chair, it wasn't too hard to reach the cables. If you get in a real awkward spot, then you're stretching and you might get uncomfortable. I noticed when I started doing a little looking around, pretty much all the telescopes right now have cables of this length. And I figured out part of the reason, at least with this one here being shorter than this, is because the telescope will actually run into it. And of course I'm sure they save money, but that's part of it. I would consider this to be light duty. It can handle, it says I think it can take up to 15 pounds. This weighs between 9 and 10 pounds, I believe. And it works real well on this. So I'd say it's a good balanced setup. There's a lot of plastic parts, so you don't manhandle it. You don't have to truly baby it, but just don't force it. And one thing I thought when I was sitting in that chair, it would have been really nice if I could have had the cables just right here in front of me. So my issue with the cables, if I'm sitting here looking through the eyepiece, it would be great if they were right down here by my hands. So I'm just comfortable sitting here like this, just moving them. As you can see, I got to reach up, which this isn't terrible. That's arm's length for me. I'm about 5'10". This other one's a little farther away. Fortunately, if I've got the polar alignment decent, I don't have to grab this one very often. So last night after I finished making the video with this, it was nice outside, and I ended up using this telescope for about 6 hours. I was out till 2 in the morning or thereabouts, and I got to look at Saturn. I hadn't mentioned that before because the night before it wasn't available. It was behind the trees. And I looked at Jupiter, and then I decided to try to find some of the brighter deep sky objects. I found M13 globular cluster in Hercules, and also M57, the Ring Nebula, and then M27, the Dumbbell Nebula. This telescope's quite capable of showing them. I was a little surprised I found a couple of those because there was a little bit of haze and smoke way up from the forest fires out west that had blown over here. There's your setting circles, which these are kind of optional, I'd say. A lot of people don't even use them. Some people hate them. They're since it's such a small diameter circle, they're not real accurate, but they can help you go from one place to another. It can help you find some of the objects that are a little challenging to find.